Welcome and hello to all our viewers of The Great Unknown, a YouTube channel dedicated to exploring and uncovering the mysteries and unknown events of the universe. We strive to delve into universal mysteries and bring our viewers along on a journey of discovery and enlightenment. We aim to challenge conventional thinking and provide a platform for alternative perspectives and ideas. Through in-depth research and engaging storytelling, our purpose is to shed light on the mysteries and unknowns of our natural world that have captivated our curiosity and imagination. Whether it's examining ancient civilizations, unexplained phenomena, or modern-day mysteries, we're committed to uncovering the truth and sharing it with our audience. If you're interested in this subject matter, we encourage you to subscribe to our channel and hit that notification bell. Doing this will ensure that you never miss out on any of our new and exciting videos as we continue to explore and uncover the mysteries of the world. In our first published video, we will be discussing the fascinating discovery of the oldest meteorite, also called the Erg-Chek 002 meteorite, which was found in the Sahara Desert. This meteorite has sparked much curiosity and speculation due to its unique composition and the strange circumstances surrounding its discovery. Join us as we dive into the mystery of the Erg-Chek 002 meteorite and explore the possible explanations for its origins and significance. First off, let's give you a little background on meteorites and the formation of the solar system so you better understand the fascination surrounding the Erg-Chek 002 meteorite. A meteorite is a piece of rock or metal that falls from space and lands on the Earth's surface. These rocks and metals are called meteoroids when they are still in space, and they become meteorites when they land on the Earth's surface. Meteoroids are formed when larger objects, such as asteroids or comets, break apart or collide with each other in space. When a meteoroid enters the Earth's atmosphere, it begins to heat up due to friction with the air. This causes the outer layers of the meteoroid to vaporize, creating a glowing trail of gas and dust that we call a meteor. If the meteoroid is large enough and doesn't completely vaporize, it can survive the trip through the Earth's atmosphere and land on the surface, where it becomes a meteorite. There are three main kinds of meteorites: stony, iron, and stony iron meteorites. Stony meteorites are made up of rock and are the most common. Iron meteorites are made up of mostly iron and nickel, and they are usually heavy and dense. Stony iron meteorites are a combination of both stony and iron meteorites and are relatively rare. Meteorites are important because they can give us insights into the early solar system and the formation of the planets. They also help us understand the composition and structure of objects in space and how they have changed over time. Scientists study meteorites to learn more about the early solar system and the conditions that existed when the planets were forming. But what exactly does the early solar system mean? Well, the early solar system refers to the period in the history of our solar system when the sun, planets, and other celestial bodies were forming and evolving. This period lasted from the formation of the solar nebula, a cloud of gas and dust that surrounded the newborn sun, to the point when the solar system reached its current configuration. During the early solar system, the solar nebula collapsed under its own gravity and began to spin, forming a disk of material around the sun. Within this disk, small particles of dust and ice began to stick together and form larger and larger bodies, eventually forming the asteroids, comets, and planets that we see today. The early solar system was a dynamic and chaotic place, with objects colliding and interacting with each other in complex ways. It was also a time of great change and evolution, as the solar system underwent many transformations as it formed and matured. Today, we're able to study the early solar system through the use of advanced telescopes, spacecraft, and other tools that allow us to observe the celestial bodies and features that remain from this period. By studying these remnants, we can learn more about the early solar system and the conditions that existed at the time. So, on the back of all this information, it might be more understandable the absolute fascination surrounding the meteorite found at Adrar, Algeria, in the Sahara Desert in May 2020. Scientists continue to try to understand how a meteorite rock, which is 4.6 billion years old, ended up in the desert in the middle of nowhere. Since its finding, the rock has been under study and scrutiny to help scientists piece together this piece of planetary history. During the month of May in 2020, a team of scientists conducting a survey of the Saharan desert came across an unusual rock, which they initially believed to be a terrestrial boulder. Upon closer inspection, however, they realized that the rock was not of terrestrial origin. Further analysis revealed that it was a meteorite, essentially a piece of rock or metal that has fallen to Earth from outer space. This ancient meteorite is believed to have originated from the asteroid belt between Mars and Jupiter and is believed to be the oldest meteorite ever discovered. The team conducted a series of tests on the meteorite in order to determine its composition, age, and origins. These tests likely included a variety of analytical techniques, such as chemical analysis, microscopy, and spectroscopy, which allow researchers to determine the elemental and molecular makeup of the meteorite. It's believed that scientists may have used radiometric dating techniques to determine the age of the meteorite. Radiometric dating involves measuring the levels of certain radioactive isotopes present in the meteorite and using this information to calculate its age. This is typically done using a mass spectrometer, which can accurately measure the levels of different isotopes present in a sample. The team may have also conducted physical tests on the meteorite, such as measuring its density and conductivity, to gather further information about its properties and characteristics. Other tests done might possibly include X-ray fluorescence or inductively coupled plasma mass spectrometry to determine the elemental composition of the meteorite. These techniques involve bombarding the meteorite with high-energy particles or intense heat, which causes the elements present in the sample to emit characteristic radiation that can be used to identify them. The researchers likely also use techniques like scanning electron microscopy or transmission electron microscopy to examine the meteorite at a very small scale, allowing them to study the structure and composition of individual grains or crystals within the sample. This can provide valuable insight into the conditions under which the meteorite formed and the processes it has undergone over time. In addition, the scientists might have used spectroscopic methods, such as infrared spectroscopy or Raman spectroscopy, to study the molecular makeup of the meteorite. These techniques involve shining a beam of light on the sample and analyzing the wavelengths of light that are absorbed or scattered by the sample. This can reveal the presence of specific molecules within the meteorite and provide further clues about its composition and history. After all these numerous tests were concluded, they were stunned to find that the meteorite was over 4.6 billion years old, making it a precious and valuable artifact that could provide valuable insights into the conditions that existed in the solar system during its formative years. It is also possible that the meteorite could contain clues about the early evolution of life on Earth, as it may contain organic molecules that may have played a role in the development of life on our planet. The discovery of the 4.6 billion-year-old meteorite is a significant one and will likely lead to further research into the early history of our solar system and the conditions that existed at the time. It is an exciting discovery that has the potential to revolutionize our understanding of the universe and our place in it. Daniel Kunama, a science engagement astronomer at the South African Astronomical Observatory who had the privilege of studying the meteorite, said that the most exciting aspect about this meteorite is the way that it formed. The rock itself appears to have formed on the crust of a planet. He explains that on Earth, we have tectonic plates that move together, and there are zones where these plates drop under the surface to create volcanoes. From this, we can understand that there is always a lot of activity happening in the crust of the Earth. Dr. Kunama further stated that the same is thought to be true about this meteorite, which came from something similar, but which was formed before the Earth was formed. This means that there probably was some sort of protoplanet in our solar system before the Earth and the other planets' formation. This protoplanet was ripped apart, and most of these rocks would have been absorbed into the Earth or by the other planets. This specific rock floated around in space for 4.5 billion years before finally crashing to Earth. This meteorite will give us a better understanding of our surrounding planets and the solar system in general. If you're interested in reading further on the results of the meteorite study, you can access the study the team published in the Proceedings of the National Academy of Sciences. We'll link the URL to the study below. If you enjoyed this video and want to stay up to date with all of our future content, be sure to subscribe to our channel and hit the notification bell so you don't miss out on any new content. Until next time, stay curious.